Diving deep into graph technology is one of the most meaningful steps towards data literacy, but there are so many methods to choose from. Philip Rathle, CTO of Neo4j, helps you navigate various graph models and the way they parallel what's happening in your database, right here on Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh, here with an old friend of mine, folks, someone I interviewed, I think almost 20 years ago. Time flies when you're having fun. He's now the CTO for Neo4j, one of the most prominent graph database vendors in the world. And of course, we're all gearing up for the big Snowflake Summit in San Francisco. And Snowflake, as I say, is a center of gravity these days, at least in the relational database world. They're doing a lot of interesting things, lots and lots of partners. But Neo4j has been doing graph database for longer than most, I'll say that. And graphs are such fascinating constructs. Of course, you may recall graphs persist data in nodes and edges. Typically, a node is an entity, and edge is some characteristic of the entity. But we're going to talk about that, a new standard that has just been adopted, like SQL, which of course has been the standard query language for databases for a very long time. And also some interesting things around property graph and graph RAG. So retrieval augmented generation, how graph can be very useful in that world as well. So with that, welcome to the show. Here we are, Philip Rathle, and formerly of Embarcadero way back when. Now you're the CTO of Neo4j. Welcome to DM Radio. Tell us a bit about what you folks are working on. Maybe let's start with just give us an overview of Neo4j, where you are now, and then let's get into the standard stuff. Go ahead.
Sure. So great to be with all of you, and thanks, Eric. It's been a long time. Great to reconnect. So Neo4j, graph database provider, and we've been, you could say, leading the way in graphs for the industry for a long time. So part of our vision, which we'll get into shortly on the standards side, is that the property graph model offers so much potential for everything from digital twin, graph RAG. Who knew that was going to happen? But right. Turns out we've accidentally built exactly the right technology over the last decade plus to ride this very important wave. But also for the kinds of real world data that you have, just that manifests between biological networks of supply chains, networks of people, networks of computers. A lot of the data that we just interact with in the real world that your company, your project needs to be able to master, can certainly fit in tables. But if the data is fast moving and it's flexible, and you want to change your requirements from one day to the next, or bring in new data from one day to the next, and understand the data relative to the shape of the network. So understanding like how communication patterns reveal different communities that are not otherwise obvious, except for doing some graph querying or multi-level supply chain risk kind of optimization. Is all right, there's a ship in the Suez Canal that's sideways. What does the world do? And then, how do you de-risk your supply chain and understand all the cascading impact? So really, we've been working on this problem of helping individuals and companies see beyond the headline, into the deeper effects, which reveal context and causality.
Yeah, that's just fascinating stuff. And you made one sort of comment there, which crystallizes in my mind the difference, right? Relational databases, rows and tables. Okay, it is technically a three-dimensional view of the world, but at its fact table level, it's a two-dimensional view of the world. And the world is very much three-dimensional. And so when you try to fit all sorts of data into a relational model, you're going to run into lots of problems. And we've talked before about how you can then flatten the data to normalize it, either to run reports on it or something, but that's a pain. It's difficult to do. And the nice thing about graph, especially what they call flexible schema graph is that you're open-ended about how you look at the world. You can load a whole bunch of customer data. The customers are nodes, their purchases, their purchasing history, maybe those are edges, but then the objects they've purchased are nodes as well. And suddenly you can start looking at the situation and understanding the shape of how your business runs in a much more intuitive way than you could trying to look at rows and tables, right?
Yeah, something I appreciate, especially with having been in the data modeling tooling space for many years, is that there's a huge distance between a conceptual, logical, and then ultimately the physical model. And so any new project, and I lived through this many times, you start doing some whiteboarding with your technical and business experts, and then 3 months later you end with this carefully normalized, denormalized, nth normal form kind of physical model, and that actually creates the basis for some real communication challenges of how does my developer who has the domain view maybe in some object model communicate what they're trying to do with the DBA, and likewise how does IT communicate with the business. And so having a model that where your conceptual, logical, physical model are very, very close, if not identical, and where also the way the data shows up in the real world and we conceptualize it as humans lands into the database in exactly that way, in a way, to your point, where if I have new kinds of data that I want to bring in, you just add it. No refactoring, no, finding a 1 hour window, per quarter where you can carefully migrate your schema.
Right. Yeah, I mean, this is fascinating. And so let's get into use cases. So there are lots of reasons people can use a graph database. I find it extremely valuable in the discovery side of the data world, because understanding what's happening and wrapping your head around the possibilities, the implications, you kind of hinted at being able to understand impact analysis, for example. This ship turns sideways in the Suez Canal. Well, how do you figure out the impact on that across your suppliers, across the companies that you serve, for your own supply chain reasons? I mean, graph allows you this really broad flexibility to be able to track dependencies and then run assessments and figure out what to do, as opposed to, again, document databases, relational databases. I mean, they have a lot of great use cases, but that use case is not really aligned with their models. What do you think?
Yeah, agreed. And much like in the relational world, you have your kind of OLTP, operational transactional world, where that usually brings in high availability, lots of transactions. And then you have your analytic world. And obviously, everyone wants those two worlds to be able to come together and be, available under one roof. In the graph world, you also have these two sorts of worlds, which, where there's a virtuous cycle between the two. So being able to explore, so you have exploration benefits and then development time benefits, as to be able to actually see and understand your data in a way that your brain thinks about it. Mm-hmm. And then there's the runtime benefits in production that generally have to do with being able to do multi-level queries and many steps removed supply chain kind of operations, or a number of car and airplane manufacturers have their entire product hierarchy inside of Neo4j. And so it's a million parts in an airplane, and it's parts of parts of parts and parts. And that ends up being a digital twin of each individual plane that follows it throughout its life as things get changed in and changed out, and you need to do dependency analysis and calculations. And then, we have some auto manufacturers who are actually taking that. There's a great video on YouTube that Volvo did describing this of, okay, I have all my parts of the car, but then who in the organization is the point person for each part? And then what functions do each of the components serve? So that if I, want to do some work on one part of the car, then I can bring all the right people to the table. And, this is accessed by everyone in their organization effectively. So coming back, there's operational graph use cases where you're doing things in real time, like recommendations, fraud detection, or frankly just having a real world, some kind of real or digital world digital twin that needs to be queried by an application. And then you've got this analytic exploratory model of, all right, something just happened in the world. I need to go and explore and analyze and visualize my way around it. So you can do that as well.
Yeah, there are many use cases. Let's talk about the standard. So in the database world, people understand ANSI SQL standardization. I think 1992 is the established one. Of course, it's 2024 now. But at least there's a standard that people can adhere to. And so any company that wants to build a new technology, as long as they adhere to the standard, they know that most people who know SQL are going to be able to use that. And hitherto, that was not really the case in the graph world, but now there is an ISO standard. Is that correct for graph?
Yeah, this is a big deal. I'm glad you brought that one up. For the last 37 years, since the initial publication of SQL, and so SQL 92 is the one most people have heard about because it was this very robust version of SQL. The initial launch of SQL was in 1987 under ISO, which then ANSI sort of inherits the ISO standard. And every new model that showed up in the intervening 37 years between then and now has basically been absorbed into SQL. It happened with objects, it happened with XML, it happened with JSON, and so on. And what the ISO committee deemed significant about property graphs is that it's such a different model. It's isomorphic with relational. Anything you can put in a relational database, you can put in a graph. But the uses are, it's a model that has such significance that there was a new standard approved in 2019 that actually was published 5 years later, just last month. So pretty big deal that you now have two sibling languages, SQL and GQL, one for the relational model, one for the relationship model, so property graphs. And yeah,
GQL, and I like that it's very simple because there was also Sparkle. I remember Sparkle is a query language, and you made a very good point that in this space, it is best to have all the competitors just agree on a standard such that it's usable by a much broader audience, right? Because usability is so important in the world. And we're seeing as a general rule now, look at open source, for example. There is this very strong movement these days in the open source community. And guess what you get from that? Standards. You get a de facto standard when you have so much emphasis on open source, and it reflects user demands, really. Users don't want to be locked into proprietary standards. It's just a very difficult thing to deal with. People don't like it. And now you even see, what was it, Google? And I think one of the other big ones has killed their egress fees for cloud hosting, which was the other big lock-in. So the point is, people don't like lock-in. And so there was an effort made to standardize across all the different graph vendors on GQL, and that has now been formally adopted, right? Last month, I guess you said?
Formally adopted last month. Vendors are, including us, are now working on it. The good news is we've also spent the last 5 years evolving Cypher, which is become the de facto language for graph querying, and most graph vendors already support that. And so the evolution from Cypher to GQL becomes kind of merging tracks, kind of gently and slowly, rather than having to jump from one track to another, which was also important to us. But it's so important to not, have a single agreed upon high quality language that the whole industry can use, that then as a practitioner, you can get much more value from your skills than if it just worked with an individual technology or a set. If you're if you're a CIO making portfolio decisions, you don't want lock-in. To your point, we want to earn our customers' business, and feel everyone should be on that same page. And then that actually provides some level of confidence in deploying more broadly, knowing that, this is an international standard.
Right.
I think also inside of academia, there are graph curricula that have existed in universities, but now that there's an ISO standard, that's going to start to show up more broadly, which will feed the pool of skills, which will help evolve things.
Right now in this LLM space, and I'll just throw some thoughts at you.
Yeah.
If you look at where we've come from mainframe to client server, well, that was a transformation. Companies had to refactor their software or rethink how to design software in the client server era as opposed to the mainframe. Then the cloud comes along. Early days, you had ASPs, application service providers. Now we have SaaS, software as a service. But still, that required a fundamental change in how we design. Then Kubernetes comes out and containerization, first Docker, then Kubernetes. And that caused a massive refactoring of how you actually design, deploy, and manage your software. I would say that what we are now seeing is another major refactoring as companies try to figure out how they're going to fit into this new AI-infused world. And really, it's all about where you fit in the RAG model, I think, because you're going to have these LLMs and foundational models, which do amazing things. We're just scratching the surface on what they can do. But there are drawbacks. There are flaws. I mean, I joked that my buddy Usama Fayyad, who was the first chief data officer for Yahoo years ago, he jokes, these new models, they're too big. They're not supposed to work. We don't know why they work. And you're like, what? This is the guy who should know almost everything about them. But my point is that I think, again, software companies are going to have to reimagine themselves in this new world, which I think is the new de facto standard. And Graph RAG plays a very interesting role in all that. So just quickly, what do you think about my theory that we have to change again? And then talk about Graph RAG and how it bakes in this semantic awareness as a first-class citizen. Go ahead.
Yeah, I mean, platform shifts cause a lot of disruption and opportunity, and what that means for the tech stack. And I'd add mobile actually to the, to your list is that each time we have this new technology emerge, then okay, you've got a whole bunch of new supporting technologies and infrastructures that need to come along for the ride. And that gives you, there's a necessity, but it's really all about opportunity. Are you going to be early and do it well, in which case you gain a competitive advantage? Or, are you defending against competitors who've already done it and then you're more in mode? And, and the same company can be doing both at the same time, right? Like in different parts of their business. But ideally, we all want to be ahead. I mean, and it's been great to see the number of companies that have just jumped on board and practitioners, trying to figure all this out. I live in Silicon Valley, and in San Francisco, there are at least half a dozen, sometimes a dozen, Gen AI gatherings per day. On weekends, it's maybe down to 4 or 5, but still 4 or 5 on a weekend day. And so we're all trying to figure this out as we go, and every day, every week, there's a new discovery. But one of the things that's been pretty clear is, do you remember when Google launched their knowledge graph in 2012? There was this blog post called Things, Not Strings.
No.
So the idea was, all right, so why was Google even the dominant player in 2012? Let's rewind a bit, since you brought up Yahoo. So in the mid 90s, web search was entirely based on just text-based search, text matching. So that was pretty impressive as an engineering feat, is to index the entire World Wide Web and then provide a front end to potentially unlimited number of users, the whole planet. And then after about 10 years, you ended up with just so much noise that you needed a way to filter that down. And so Google launched, and they were not only the biggest search engine at the time, but they had PageRank. And PageRank turns out to be a graph algorithm that lets you prioritize and rank your pages, so your top 10 blue links, based on how many inbound links there are. And then this is iterative. How many inbound links do those have? Let's weight those according to that. So Google became dominant because of that one invention, one graph algorithm.
Wow.
And then a decade later, what happened is, this is all in the domain of words and strings, with a little bit of graph augmentation, is, you search for Rio, and do I mean Rio the movie? Do I mean Rio the city? Do I mean Rio the hotel? Do I, mean something else? And so they started to inject meaning into the queries. So you ended up with a Google Knowledge Graph, and this is where you search for a movie, and you get this panel to the side. It's called a Knowledge Graph panel.
Right.
And then you can actually navigate the graph. So we're in an era now where people are at the leading edge are figuring out that LLMs deal purely with words. Vectors deal purely with words. Now, it turns out you can do you can get impressively close to human meaning just by playing statistical games with words through LLMs and vectors. But, this is your observation that your friend's Yahoo's observation of, man, we don't know how these things work, but they're pretty good. But on the other hand, like hallucination, these things are going to continue hallucinating, not having specific enterprise knowledge, not being able to relate things, or come up with exact answers or be explainable. They're all a black box. And so
Right.
knowledge graphs end up being a perfect complement to vectors. And you hear the term graph RAG coming up, which is doing vector-based search, doing retrieval augmented generation with not only data from a word vector embedding, but also bringing in data from the knowledge graph.
See, and I think this is the key. And so my theory here is that, I mean, first of all, these foundational models are so powerful, they are going to subsume most of traditional enterprise technology sooner or later. This is my theory. Maybe not. It's hard to say. I mean, I've never actually been more unsure about what's coming, at least specifically, because it's just hard, right? Because these things are very, very powerful, but they are centers of gravity, and they're just going to attract engine and activity and interest and financing, et cetera. So they're big and they're changing things. So the key is going to be, what is the workflow around this engine? And that's what RAG was from the first place in originally, right? Is retrieval augmented generation over at Facebook, or Meta, I guess they call it now. They realize, all right, this thing it just goes off and does crazy things unless we have to kind of hold it down. So these are your constraints, or anchors of truth is what someone referred to them in terms of the embeddings. But you can get very clever about the RAG model. And what I love about this graph RAG thing is that basically in the model, as you do your prompt, it's going to go and check for this semantic layer first and align semantically, and then grab some information, grab the text generative capacity of the LLM. And then you could even do some fact checking and some governance on the way back before it gives you the answer. So it's like you got little fact checkers. And that's kind of what these transformers do anyway, right? Is that you have this additional layer of decisioning on top of the initial layer, which is now you have like 5 little bots saying, I think it should be X, I think it should be Y, I think it should be Z. And the guy on top says, I'm going to go with Y on this one. So you're building in layers of reconciliation, really, and using the semantic organizational capacity of graph to really align and true that wheel. What do you think about that?
Yeah, I agree. And one way to look at it is, if you look at the brain, you have your left and right hemispheres, and they each play a different role. And if you have just one, then okay, so right brain we usually think of as being spontaneous, creative, not really explainable. It usually makes great decisions. Sometimes they're spectacularly bad, and I have no idea why I did what I did, but I did it.
Right.
And
that's funny.
And this is how LLMs behave. Like, we've all experienced it. Anyone who's played with ChatGPT, even 4.0, knows this. And why is that? It's because it's based on this. It is inherently this black box model that is built on a word model. And so, we kind of think it's a world model, but it's a word model that, kind of approximates that. But so what does the left brain look like? It's concrete, it's rational, it's deterministic. You'll reason through the same decision every time and get to the same conclusions. And so so graphs become then the left side of the brain. And for Gen AI, we actually want both. You want, your creativity and your spontaneity and, being able to draw from all this knowledge and have mastery over words.
Right.
But then you also want to be able to get visibility control over, these guardrails or kind of loading the dice as you were describing with vector embeddings, where you narrow your margin of error. With GraphRag, you can either narrow it further if you're delegating the reasoning to the LLM, or if you're doing the reasoning in the graph for things where you need an exact answer. How tight am I going to tighten the bolts on an airplane? Like that, there's no room for even 0.01% error.
Right.
Then you do the query in the left side of the brain, and then the LLM helps to reformulate the answers and bring it into language.
That's really fascinating, and I'm going back to an epiphany I had. This is in fact before the Gen AI stuff even came out and became popular. But I was asked to give a talk on AI versus data warehousing, and what I basically said is it's not going to be AI versus data warehousing. It's going to be data warehousing and AI, and they are different things. And the concept I came up with, I'd love to get your thoughts on this, is that when you have both, you can get depth perception. Because basically the data warehousing is going to be this deterministic component. The AI is going to be more stochastic in nature and discovery oriented, which is very important to think outside the box, so to speak. Like literally, the data warehouse is a box and AI is thinking outside the box. But what I said is one is like your left eye, one is your right eye. If you have only one eye, you don't have depth perception. You need the triangulation of two eyes to be able to see where something is close to you. So that my argument back then was, what you want to do is find a way to strategically fuse these two views of the world in some meaningful way. That's going to be inside a RAG model right now, whether it's at the end or at the beginning. The point is there's going to be a workflow around this stuff, but you want to keep your deterministic view of the world, the data warehouse, but you also really want to have this other view of the world. And to your point, graph is a huge part of bringing all this stuff together. But what do you think about that whole analogy and where I'm going with that?
Yeah, and it's funny. I see that analogy with data warehousing and Gen AI. I think that's right. I also see that analogy with, kind of the left brain, right brain of your knowledge graph is your source of truth for, data in the real world, like we were talking about earlier. Of I have a digital twin of some complex system. The data warehouse will be your source of truth for, maybe sales orders and all the various transactions that occur in your business. But then you also need a source of truth of how things are connected. Now, it's something we're actually announcing at the Snowflake Summit. Can I talk about that?
Yeah, go ahead, real quick.
Yeah,
tell us.
Yeah, great. Is actually being able to bring the data warehousing world closer into the graph world. So you'll actually be able to, and this is something that's actively being worked on, should GA in a few months, of being able to run inside of your Snowpark container service, rip data out of the tables that you want in Snowflake, run some graph computation on it, and then push it back in, and then it's a serverless ephemeral graph service.
Wow. That's the announcement you're making. That is very, very, very cool. And what is that called? Is there a name for that?
It's graph data, Neo4j graph data science.
Neo4j graph data science. This is absolutely fascinating stuff. We have to get you back on the show sometime. Folks, we'll be talking to Philip Rathle, CTO of Neo4j, one of the longest standing graph vendors out there. Very, very cool stuff.